For our last set of notes of this unit before our exam, and just a reminder that exam will be on Tuesday, we're going to look at perimeter, circumference, and area today. The first thing we're reviewing is which of these shapes are polygons and which are not. So remember the definition of a polygon: none of the sides cross, no lines cross, and it is a closed figure. And it is composed of lines. So the first example here, this arrow, that is a polygon. The second one that we have is the rectangle with the X through it. This is not a polygon because of those intersecting lines. The third example is these two extending rays. Because this is not a closed figure, had it had a line across through here, it would be a polygon. Our fourth example, that is a polygon. And the fifth example is a circle. Remember, a circle is not a polygon. And then this last one is just an E. That's not a polygon. It's not a closed shape. Each one of the four figures in example 2, we're just going to name those. We should be pretty comfortable with naming these. The first one is a circle. Our second figure is a rectangle. The third figure is a square. And the fourth figure is a triangle. Okay. Vocabulary for today, we're looking at the word consecutive. Consecutive just means to follow in order. Now, that doesn't necessarily mean like 1, 2, 3, 4, 5. That is consecutive. It could also mean 1, 3, 5, 7, 9. Those are consecutive odd integers. We could do 2, 4, 6, 8, 10. Those are consecutive even integers. It just has to be in order as we go through the step. There has to be a pattern to it that holds. The example that they give right here, you have 2, 4, 6, 8. Those are consecutive even integers. We just did that. 1, 3, 2, 5, 4. There's no pattern to that. That is not a consecutive set of integers. For using the vocabulary, we have column A. We're given a sequence of letters. Then we want to match it up to the next letter in that sequence. For number 3, we have L-M-N-O, so it would stand to reason that the next one would be P, L-M-N-O-P. Example 4, V-U-T-S. Well, that's just going backwards through the alphabet, so the letter that precedes S in the alphabet is R. And for our last one, we have A, C, E, G. We are skipping every other letter. So instead of we go from A, we skip B, we go to C. We skip D, we go to E. We skip F, go to G. We skip H, and we go to I. Okay, those are consecutive, even though we are skipping, but the skipping pattern is consistent through the process. For number 6, we're just going to label the parts of each one of these figures. We are given down here in the bottom the perimeter and area formulas, or in the case of the circle, the circumference and area formula, using the different components of each individual shape. For the first one, we have the square, and the perimeter is the side multiplied by 4, or you could just think of it as adding all 4 sides together for a square. Because one of the key definitions of a square is that all sides are equal. So you could take one side, multiply it by 4, and you have the perimeter. The area of a square, you take one side and you square it, and that'll give you the area. For a triangle, the perimeter of a triangle is found by adding up the individual sides, A, B, and C. And to find the area of that triangle, it's 1/2 base times the height. And the height is that vertical dotted line you see extending from the base up to the vertex. For a rectangle, the perimeter is found by multiplying twice the base and then adding twice the height. So our base is indicated as the longer side here, and then we have our height is the shorter side. And to find the area, it's base times height. Finally, we get to a circle, and the parts of the circle that we want to label. The circumference, that capital C, measures the distance all the way around the circle. The radius that we see with this shorter line here extends from the center of the circle out to its perimeter. And then finally we have the diameter, and a diameter is any line that passes through the center of the circle, extending to opposite sides. And we can find the circumference of a circle by pi times diameter, or 2 pi times the radius. The area is going to be pi times r squared. Well, okay. For our first problem on here, man, I'm going to make it through this one day without this doing this to me. All right, finding the perimeter rectangle. We want to frame a picture that is 5 inches by 7 inches with a 1 inch wide frame. So let's draw this out and kind of get an idea. Here's our picture. It's 5 inches by 7 inches. And we have a frame that is 1 inch wide that's going to go around it. Okay, so that's 1 inch all the way around. We know that the picture is 5 inches by 7 inches. And actually, I don't know why they don't even bother to ask us anything about the frame. So the drawing is more or less useless except for the red drawing there with the picture. The circle, the formula that gives the perimeter of the picture, where we're dealing with a rectangle. The perimeter of a rectangle is twice the base plus twice the height. So we're going to solve this by substitution. The perimeter is equal to 2 times 5 plus 2 times 7. When we simplify, we get 10 plus 14. And our final answer is going to be 24 inches. So the perimeter of the picture is 24 inches. Make sure that when you're given units in a problem, you include the units in your solution. For our second example, we're going to find circumference. And with this particular problem, we're given an example of student work, and we're going to determine where the mistake was made. So when we read the question, it says, what is the circumference of a circle with radius 24 meters in terms of pi? So when we see something where it says in terms of pi, all that means is pi will be part of our answer. We're not going to multiply out by 3.14, which is an approximation of pi. We're not going to multiply it by using pi on the calculator. We just leave our answer in terms of pi. So if we look at the circle that's over here on the right, we see that the student has labeled the diameter as 24 meters. But if we look back at what we were given, the radius is 24 meters. So really what the student should have done was put the radius at 24 meters rather than the circumference. So their mistake was they substituted radius in for diameter when they should have used 24 for the radius, which would mean that the diameter is actually 48. So the student incorrectly labeled the radius. All right, so find the correct circumference. If we use the equations circumference equals pi times diameter, we know that the diameter is twice the radius, so that would be 48 pi meters, or we could do circumference is equal to 2 pi r. The radius is explicitly given to us as being 24 meters. 2 times 24, again, is 48. And we get 48 pi meters. So the error that the student made was just they incorrectly labeled the diameter. They used the value for the radius as the diameter. Problem number 3, we're going to find a perimeter in the coordinate plane. And with that one, we're going to graph a quadrilateral JKLM with vertices at -3, -3. So that's our vertex J. At 1, -3, that's our vertex K. L is at 1, 4. And M is at -3, 1. If we connect these dots to create the quadrilateral, we want to be able to find its perimeter. So we're going to use the justifications to find the length of each side. For JK, we're using the ruler postulate. We're just finding the distance between J and K, or we could just simply count up the squares. From -3 to -1 is -4, or sorry, -3 minus 1 is -4. The absolute value of that is +4. So it's 4 units from J to K. From K to L, we have 4. Let me highlight this. So from K to L, we have 4 minus -3. So we're measuring from L down to K. 4 minus -3 is +7. The absolute value of 7 is 7. For J to M, again, this one is just a straight vertical line. It's going to be -3 minus 1. And that's going to give us -4. The absolute value of -4 is +4. Again, you can verify this by just counting. So from J to M, we have 1, 2, 3, 4. That's 4 units. That's exactly what we calculated. For M to L, we're going to have to apply the distance formula because this line is on a slope. So we're going to use the vertex coordinates for each point. And let me highlight those up here. They're not cross them out. Let me highlight them. There's M and there's L. And those are the 2 points that we're looking at for this next portion. So from M to L, we have the 2 x coordinates listed first, x sub 2 minus x sub 1. And then we're going to do y sub 2 minus y sub 1. So we have 4 minus 1 quantity squared. 1 minus -3 is +4. 4 minus 1 is 3. 4 squared is 16. 3 squared is 9. 16 plus 9 is 25. And then the square root of 25 is 5. So our distance here is 5 units. And let me label these as well. We found those. So to find the perimeter of this figure, we just add all of those sides together. We have 4, 7, 4, and 5. And when you add that up, 4 plus 7 is 11. 11 plus 4 is 15. 15 plus 5 is 20. So the perimeter of this is 20 units. For problem number 5, we're going to find the area of a circle. We're given the diameter is 14 feet. What's the area of the circle in terms of pi? So we have the diameter is 14 feet. That means the radius is 7 feet. And when we use the formula for area is equal to pi r squared. We substitute in that radius of 7. And when we square 7, we get 49. So the area of the circle is 49 pi square feet. For this next postulate here that we're going to look at, it's the area addition postulate. The area of a region is either the sum or the difference of the areas of its non-overlapping parts. And that would be the sum of the areas of its non-overlapping parts. And we're going to see that here in our next example. And that should make a little bit more sense. So we have this figure below. It looks like a staircase. And it shows one way to separate the figure that's drawn over here at the left. And down here at the bottom, we want to think of how can we separate this figure into other shapes or something that's manageable where we can compute areas. Because if we were simply asked to find the area of this figure as it's given without breaking it up into some different shapes, it'd be very difficult to figure that out. So you can see with the way they've divided it right now, we can find the area of this square, we could find the area of this rectangle, and we can find the area of this rectangle. And we have enough information there to find all 3 of those areas. Then we would just simply add them together and we would be able to compute the area of that irregular shape. With the 2 drawings presented here at the bottom, we want to draw 2 different ways that we can set these up to come up with the areas other than the one that's already presented. So it says separate the left-hand figure into 3 squares. So if we were to divide this up into 3 squares, that's not too hard to do. We can see that we have this square, I'll call it square 1. We have this smaller square over here, we'll call it square 2. And then we have this larger square in the middle that we can call square 3. So we could have divided the figure up that way and come up with its area. Another way that we could have done this was maybe to draw rectangles this way, or we could do a rectangle here, and a square. We could do 3 squares and a rectangle. There's multiple ways you can do these, just as long as it's some way that you split it up where you can calculate individual areas of the individual shapes. Then you can actually add them together to come up with the area of the irregular unit or irregular shape. The final thing here, the lesson check. It says your friend can't remember whether 2 pi r computes the circumference or the area of a circle. How would you help your friend? Underline the correct words to complete each sentence. Area involves square units. Area of any shape is always going to be square units. Circumference or perimeter would involve individual units. The circumference 2 pi r relates circumference because we are dealing with units. Right here on r, it's just r, it's not r squared. So anytime we have just a individual unit, we're talking about perimeter or a linear measurement. When we have square units, we're talking about area. And when we have cubic units, we're talking about volume. So that's our last set of notes. We will review prior to the exam, but I'll release the test on Tuesday of next week. And like I said before in class today, please make sure you guys are asking me questions if you're stuck. I'll be happy to help you.